Good morning. Today we'll see an analysis vibration to solve in structural dynamic and simulate this problem with Python code. We can see here the the problem. We have a support beam of length L carried a mass at its midspan and show in the figure 1. The beam is massless, not have mass, and we can write the equation of motion. The first step to have the equation of movement is necessary to calculate the flexure stiffness of the beam. It is carrying a load mg, and it is midspan. You know that under the vertical load Wv at midspan, the vertical deflection is Wv per L length of beam elevated at 3, divide for 48 for the module elastic of beam, multiplicate for its inertia, moment of inertia. So kappa is the flexural stiffness, is W divided for the displacement delta equal 48 for the module elastic of material of beam for inertia of beam divided for length of beam elevated at 3. The equation of mod in direction x, in this case the vertical, is m the x point plus k for x equal at 0. You put the value calculated before, this is the equation. Now we can put the parameter. Example, concentrated mass, we can take 1500 kilo, the span length 6 meter, the elastic mode for example for the steel is 200 for 10 elevated F Pascal, and the moment of inertia we can put 4 for this elevator when 5 meter elevator 4. We can calculate the kappa, the spring constant, so is the value in Newton per meter, and after we can calculate the natural frequency formulation. The circular frequency is equal a 34.4 radian per second. The frequency is 5.48 Hertz, and the system period is equal at 0.18 seconds. We given this in simple harmonic motion, so we given the initial condition x0 is equal at 0.02 meter, 2 centimeter. The speed velocity, the velocity of 0 is equal 0. So xt is equal to x0 for coseno di omega t for omega t is the equation. We can see now the the equation, so you can see here the code Python with the value define system parameter we defined before, the calculation of equivalent stiffness kappa, the omega natural circular frequency, and omega n is Fn is natural frequency is calculated in this way, and start the time with 0 to 500 data points. The initial displacement is equal to 2 centimeter. The velocity is initial velocity is equal to 0. The equation of movement xt x equal to x0 plus multiplied por coseno di omega n for multiplied per the time t. In the line of 67, 87, we plot the displacement in function of time, and we can see the result. Okay, this is the figure for where t is the axis in the axis horizontal axis, and the displacement in the vertical. Okay, this is the result of our Python code. After we can put C and a simulation to understand what real happen. So is the vibration of a beam with the mass and the curve during the time. Okay, after it's clear, you can change the value of input in the Python code to have the different graph with different amplitude and different equation. Okay, result. Okay, thank you. Bye.